So this section is on complex numbers, and let's first note. Remember that an imaginary unit, we're going to label that I, and the imaginary unit I is defined as I equals the square root of -1, where I squared equals -1. And then if I wanted to, I can continue a pattern. What would I cubed equal? Good. And then I to the 4th power is going to equal? And I to the 5th power is going to equal? -I. Okay. Or actually, it's just I. And I can continue that pattern indefinitely because there's this little cycle between the exponential increase in imaginary units. Something to keep in mind when we're talking about complex and imaginary numbers is this is the standard form of a complex number where we have our real part and our imaginary part. So an example would be 2 plus 3i. 2 would be the real part and 3i would be the imaginary part. If there's no a or no real part, we say that that's a pure imaginary number. So an example of that would be 2i. So if it's by itself, it's a pure imaginary number. And technically, there's also the real part, which is, in this case, would be 0. When we're looking at our complex number system, it's broken up into concepts of real numbers. And remember, real numbers includes whole numbers, integers, rational numbers. And imaginary numbers now we're introducing include the concept of I. And here are some examples of that. And here all this is saying is if I have 2 plus 3i, then it's equal to 2 plus 3i. Okay, so long as these components are the same. That's what this is saying. So here's our first example. It says to express as a multiple of I. Please get in the habit of always evaluating the square root of -1 first. I know you're tempted to just write 4i, but I want you to get in the habit of doing this so you don't make an error in the future. So square root of -1, we said that is, and square root of 16 is. The standard form of that is going to be 4i. Okay. What do the properties of exponents tell us? How would I rewrite the second expression? 7 squared times I squared. Good. And 7 squared is? And I squared is? So when I rewrite this, what does this equal? Good. When we're adding and subtracting complex numbers, we're going to treat I as a variable and we're going to combine like terms. Let me show you. Take a look at this example number 2. It says to perform the indicated operation. So let's begin with this first one. I want to begin by distributing that negative. That's always going to be first if I'm subtracting terms. So this is going to be 7 plus 4i minus 9 plus 5i. Now I can combine like terms. 7 minus 9 is?
2.
-2. And 4i plus 5i is 9i. I can no longer combine like terms, so that's my final answer. And it's in standard form. Real plus imaginary part. The real part, the imaginary part. Okay, let's take a look at our second example. I have 8 plus 3i plus 17 minus 7i. Here, because I'm not subtracting, I can just go ahead and combine like terms. So I'm going to go ahead and do that. 8 plus 17 is? And then I have 3i minus 7i is? And I'm done. My real plus my imaginary part. When we multiply complex numbers, what we want to keep in mind is that we're going to be foiling and that we're going to be replacing I squared with -1. So let's take a look at an example. Okay, so here's the first one. I want to perform the indicated operation. So I'm going to go ahead and I'm going to FOIL. So remember first, 3 times 6 is?
18.
3 times -2i is? -5i times 6 is? And then my last term, I have -5i times -2i. Good, it's 10i squared. But what do I know about I squared? It's -1. So here, what's really going on is 10 times negative 1. So that is what? Okay, so let's rewrite it. 18 minus 6i minus 30i minus 10. Now I can go ahead and I can combine like terms. That's going to be these two and these two. So what's 18 minus 10? Negative 6 minus 30i. Negative 36i. Okay, here's part B, and I'm going to treat this the same way, but it helps you go ahead and write your binomial 2 times. So that way you could see that you're really, this is what you're foiling. So we're still going to do first, which is 4, outer, which is negative 6i, inner, negative 6i, and last, which is positive 9i squared. But that 9i squared is really good, so let's rewrite it that way. Now I can combine like terms, these two and these two. What's my final answer? Good. So conjugate of a complex number. The conjugate of a plus bi, I think it's easiest to see this if, let me put in some fake values. Okay, so let's say I have 2 plus 3i. So a is 2 in this case and b is 3. The conjugate pair is everything's the same except the sign is different. So the conjugate would be what, guys? 2 minus 3i. Good. That's what this is saying too. So if you have the negative, then it's going to be the positive. Okay? So when you multiply a complex number by its conjugate, you're going to end up with a real number. So if I were to multiply these two together, I'm going to get a real number. Here's an example, but using variables. And notice that here we end up with the difference of 2 squares, but the I squared gives us the sum of 2 squares. Okay? Let's take a look at an example. Example number 4 says, write a complex conjugate of the complex number, then multiply the number by its conjugate. Okay, so 2 parts. We're going to write the complex conjugate, and then we're going to multiply the conjugates together. So let's do a first. The first thing I want to do is identify the conjugate. Good. The second thing I was asked to do is to multiply them together. But notice that the concept is similar to the difference of 2 squares. And remember, when you have the difference of 2 squares, you only have to multiply the first term and the last term. You don't have to FOIL it all the way through. If you go ahead and do FOIL it all the way through, you will see that your middle terms reduce. So I'm only going to go to first and last because I know that I have a conjugate pair here. So 7 times 7. And I have negative 10 times 10. And I times I. Okay, what does that I squared do? Good, so really it's going to be 49 plus 100. And what do we get? Good, 149 is our answer. Let's take a look at B. Alright, so here's B, and we're asked to identify the conjugate. I think it would be helpful if we re-express it. Remember, I have to take out the I first, so this is I root 5. What's the conjugate to this? Remember, it's what you see, but the sign is opposite. So with negative I root 5, good. And the second thing I asked you to do was to multiply them together. So let's go ahead and multiply them together. I'm going to have I root 5 times negative I root 5. What do I get? Negative I squared times what? Times 5, good. And remember, I squared is negative 1. So what do I end up with now? Positive 5. That's my answer. Alright, when I have complex numbers in fractions, alright, I went ahead and I rephrased this. What this is saying is, to simplify fractions that have an imaginary number, so if I see I in the denominator, I'm going to multiply the top and the bottom by the conjugate pair. That's what this is saying. Alright, so here's an example of what I was just talking about. So we're going to divide and express the result in standard form. So I want to actually do B first, and then I'm going to look at A. So what I said before is we begin by identifying the conjugate pair of the denominator, and then I'm going to multiply that conjugate pair to the top and the bottom of this fraction. So what is the conjugate pair of 5 minus 9i? Good, 5 plus 9i. So we're going to multiply top and bottom by this. But remember, because the denominators are conjugate pairs, I only have to multiply the first and the last. So let's go ahead and re-express this. I'm going to get 25, good, minus 81 I squared, good. The top, I have to FOIL all the way through because there's no relationship to them. So we're going to do the first. 7 times 5 is 7 times 9i. Then we have 6i times 5. Okay. We get 30i, and then I have 6 times 9i is, good, 54i squared. Alright, now we're going to simplify the top. 54i squared is really negative 54, good. And 35 plus negative 54 is negative 19. And then here I have 63i plus 30i is 93i. And let's simplify the bottom. This is really what? 81, and it's positive because of the I squared. So the negative becomes positive. 25 plus 81 is 106. This is simplified. I can't reduce anything, so it stays. Alright, we're going to do the same thing here. I could shortcut it, but I don't want to confuse you. So let's start easy. What is the conjugate pair for 5i? Negative 5i. Let's reduce it. What do we get at the top? Okay, at the top we get negative 15i. At the bottom, what do we get? We get negative 25i squared, but the I squared becomes negative 1 times negative 25 is 25. So here we get negative 15i over 25. Does that reduce? Yes, 15 and 25 have a common factor of 5. Reduce it by 5, what do you get? Negative 3i over 5. Do you see that it's the same numbers? So when you have a fraction, that's always going to be the pattern when you only have this component to it and you don't have the binomial. So technically you can shortcut just by multiplying the top and bottom by negative I. Only if it looks like this. If not, if you got confused by what I said, go ahead and do it this method so you don't forget that you're always multiplying by the conjugate pair. Alright, so what the principal square root of a negative says is just basically express the root in terms of I, then continue to simplify. This is what I was saying to you guys before a couple slides ago. So let's take a look at example number 6. It says perform the indicated operations and write the result in standard form. So the first thing you want to do is re-express the square roots, negative square roots in terms of I. That should be step 1. So I'm going to take the I out. And now I'm going to go ahead and simplify that. Okay, when I simplify that, I want to re-express the square root of 54 by 2 factors, of which one I can take the square root of. What are those factors? Okay, good. So I have the square root of 9 times the square root of 6. What about 24? Okay. 4 and 6. Good. And now I'm going to re-express it. So the square root of 9 is?
3.
And the square root of 4 is? So be careful here because this is a monomial of which I have to multiply these together. So what do I get? Good. Are these like terms? Yes, they are. You treat the square root as if it was a variable. Okay? Because these are the same, and because there's also imaginary components to them, I can combine them. If the I was missing from say right here, I can't do it. If this was the square root of 3 and this is the square root of 6, I can no longer combine them. But because they are the same, I can combine them. They are like terms. So what's 3i minus 14i? So now I'm going to go ahead and combine like terms. What's 3i minus 14i? Square root 6, and that's my final answer. Alright, example number 7. Example 7 says perform the indicated operations and write the result in standard form. So let's take a look here. Here I have a negative square root. I want to take out the I first before proceeding. So when I rewrite this, I'm going to rewrite this as 4 plus I root 7. Okay, it's squared, so remember that's the binomial squared. I think it's easy just to express it like this and then go ahead and FOIL. So we're going to do first, 4 times 4 is? What's the next thing I want to do?
I root 7 times 4.
Good. You have to FOIL it all the way through. Do not skip just to first and last just because you think it's a binomial squared. This is not conjugate pairs. Okay, don't confuse the two. So I have to FOIL this one all the way through. So this becomes 4i root 7. Inner is 4i root 7. And last is I squared and 7i squared. This becomes what?
Negative 7.
And 16 minus 7 is? 4i plus 4i is? Okay, and this is simplified. This is my final answer. Alright, part B, I'm going to begin similar fashion. I want to begin by evaluating the negative first. So let's rewrite it. We got negative 8 plus I square root 48 over 4. Okay, and square root of 48, think of factors. The highest factor that you could take the square root of for 48. Okay, can you take the square root of those numbers? Okay, good. It's 16 and 3. So that's going to be negative 8 plus I square root of 16 square root of 3 over 4. And the square root of 16 is? 4. So this becomes negative I plus 4i root 3 over 4. Please be careful when simplifying here. Unless you can factor a number out from the numerator and reduce it with the denominator, you cannot simplify this any further. Here it works out that I can factor out a 4 from the top and get negative 2 plus I root 3. If I was unable to reduce it in this method, I would not be able to reduce this. It has to be consistent factor in all three terms. So I'm going to go ahead and rewrite this as negative 2 plus I square root 3. Okay, example number 8 says use the quadratic formula to solve. Okay, and the quadratic formula, remember, is x equals negative b plus minus the square root of b squared. Good. Excellent. So I'm going to go ahead and I'm going to substitute it. And after I substitute and simplify just a bit, I'm going to rearrange it so that way it mirrors some of the homework problems you're going to see. So here we have x equals negative 16 plus minus 16 squared minus 4 times 15 all over 2 times 4. So let's start simplifying that. When we do that, it looks like this. X equals negative 16 plus minus the square root of, what 16 squared is?
4. 16 squared.
And 4 times 15. Excellent job. And then the denominator. Look at this. Okay. In your homework, in here the difference is going to be negative. Here it's not working out too clean. So let's pretend, for the sake of the example of complex numbers and your homework, that we ended up with the following. Let's say I got x equals negative 16 plus minus 240 minus 256 over 8. Now you will clearly see that you end up with negative 16, the square root. This is what you're going to see in your homework. All right. What's the square root of negative 16?
4i.
Good. So here I get negative 16 plus minus 4i over 8. What's the common factor? in all three terms.
4.
Okay, unless we had it in, if we didn't have it in all three terms, we would not be able to reduce by 4. Okay, so be careful. So here, because it's consistent, I'm going to go ahead and reduce everything by 4. And 16 divided by 4 is? Good. And 4i divided by 4i is?
1i.
And 8 divided by 4 is?
2.
And that's my answer.